Dear students, welcome to the class. Today's class we are going to discuss about the topic antenna and wave propagation, frequency independent antenna and measurements. Presented by myself Managa Devi, Assistant Professor, Department of Electronics and Communication Engineering, Hindustan College of Engineering and Technology. So these are all the outlines of today's presentation. What is frequency independent antenna? Example antennas, types of log periodic antenna, general characteristics of antenna. So what is frequency independent antenna? FI is nothing but frequency independent. The antenna contains its own scale model paths, continuous or discrete, that can be scaled to an infinitesimal size. An antenna radiates most of the power in a finite active region so that it can be terminated with a minimum effect. Fed from the high frequency end, the antenna must be a transmission line to carry power to the low frequency end. The dimensions of the active region must scale with wavelength. The antenna must not radiate in the direction of expanding. So these are all the examples for frequency independent antenna, spiral antenna, helical antenna, log periodic antenna. So see, these are all the some examples for frequency independent antenna. So the first one is spiral antenna. So what is meant by spiral antenna? The spiral antenna belongs to the class of frequency independent antenna that we already discussed. These antennas are characterized as having a very large bandwidth. Spiral antennas are usually circularly polarized antennas. So spiral antennas are widely used in the defense industry for sensing applications where very wideband antennas that do not take up much space are needed. This is the shape of the spiral antenna. The first one is Archimedean spiral and the second one is the logarithmic spiral. Here the plus and minus indicates the dipole. So this dipole is connected in the spiral shape. So this is the shape of the spiral antennas. Next, helical antennas. So helical antennas are helix antenna in the antenna in which the conducting wire is wound in helical shape and connected to the ground plate and with a feeder line. It is the simplest antenna which provides circularly polarized wave. It is used in extraterrestrial communications in which a satellite relays. The helical antenna is used for satellite communication due to its high directivity and circular polarization of the transmitted electromagnetic waves. So next one is working principle of helical antenna. This is the shape of the helical antenna. So this is the inner conductor and this one is the outer conductor which is connected to the coaxial cable and ground plate. So this S represents the helix, the distance between the two helix, and the D is the separation. So this is called as a helix. So this is the physical structure of helical antenna. So this one is the ground plane and this is the feeding point. This is helical antenna, air-filled cavity and a silicon rod. The next type is a log periodic antenna. A log periodic antenna, or simply we can call it as a LPDA, log periodic dipole array, also known as log periodic array or log periodic array. So it is a multi-element directional antenna designed to operate over a wide band of frequencies. The horizontal beam width of the log periodic is approximately 45 degrees and it should be pointed or aimed in the direction that the received signal is coming from. This is the geometry of log periodic antenna. Here the antenna elements are arranged as a spacing angle of 2 alpha. Here the distance between the each dipole is S1 and the distance of dipole, the dipole size is dn. So this is the feeding line. The antenna elements are connected in the log periodic structure and connected to the transmission line. Next, general characteristics of these frequency independent antenna. So each independent antennas having their own radiation pattern, bandwidth, polarization, directivity, frequency, beam width, effective area, power density, velocity, standing wave ratio, aperture. So thank you students. We'll discuss remaining things in the next class.